So, shout out to Dr. DeLay for presenting stellar metamorphosis in an official university course. At the very end of one of his last classes, he presented the stellar metamorphosis graph, where I present the idea of young hot stars that are big and bright and hot, cooling on a slow, steady continuum until they become planet-like. I'm sure that spurred the imaginations of a lot of individuals in that class, and it was a major relief for me. Definitely appreciate it. I say relief because I know that not all is lost in terms of astronomy and human beings understanding the stars. Now it's up to us. Hopefully more people understand. I know my listeners understand, but it's very important. Becoming more of a historian of science now. Every now and then I stumble upon papers and connecting the dots, so to speak, as to how things got to the way they were. Expanding Earth and Static Universe, 2 papers of 1935, written by Helge Krag. I don't know how to pronounce his name. I'm going to link this to the bottom, but basically, Helge Krag is a historian. He's a lot older now. He's, I think, about 80, 81. He's written a lot of stuff, physics related. He wrote about Jacob K.E. Halm in this document, who lived from 1866 to 1944. Cartoon of Halm, Cape Times. This is reproduced from Glass 2014. This is Halm in September of 1908. There's a good picture of him. You see him with hands in his pocket, just looking out, doing his thing. I'm pretty sure my mustache would be that glorious if I were to take this off, but as opposed to the wife's demands, I'm not going to do that. But Halm had written 2 papers on 2 different subjects, one on an astrophysically based argument for the expanding Earth, and the other a no less original attempt to explain galactic redshifts on the basis of static structure. But Krag here never mentions the really gold that Halm was discussing, that just completely went over his head. And that is that Halm, J.K.E. Halm, H-A-L-M, Ph.D., an astronomer no less, the president of the Astronomical Society of South Africa, wrote in Volume 4, Number 1, in the year 1935 of November. Here he is. For those, if you want to look at it, look it up. Check this out, November 1935. He was 69, 70 years old when this went out, so I'm pretty sure he had the idea before this. I'm going to read it out to you, word for word, because it's, wow. Let's see here, where did I write it? Star stage. Uh-oh. Technical difficulties here. I had it right on my finger and then I just moved it. Now for the latter, obviously 2 courses in opposite directions are open. Either we may try to trace the development of the Earth from an earlier stage to the present, or we may take the opposite course of tracing the course of events in the backward direction from the present to earlier stages. The former is a procedure adopted by an astrophysicist who studies the evolution of the celestial bodies from earliest evidence of existence to the end of their career as luminous bodies. The latter course is taken by the geologist who endeavors to obtain a picture of past stages in the Earth's evolution from the evidence of the relics of these stages and the present formations of its surface layers. What he's saying here is that the geologist and the astronomer can both see an observation of an incoming bolide going in an arc, and he says, well, it's straight from, you'll read this in the paper, I'll link it, you'll see that straight from A to B over here, and it's straight from C to D over here. So they extrapolate and they go this way, and then they reach baseless conclusions. Right here, they take a linear progression of events, they extrapolate that, and they go here. So completely different spots, completely different timelines based off the assumptions on linear progression of the observations from either person, the astronomer or the geologist. What he's saying here is the hyperbole hyperbola, I don't know how to pronounce that. Hyperbola is curved. So they are both right, but they're missing that central region of when it curves. So the astronomer is correct, but not taking his conclusions to the correct direction. And the geologist is correct, but not taking his conclusions to the correct direction. Both are actually leading towards each other, right in the middle. Right there. That's the short skinny of it. That being said, the geologist therefore is well advised not to place too much reliance on conclusions regarding the evolution of our planet, which are based solely on the properties of matter as he observes them under very limited conditions accessible to his observations. We must insist that his conclusions, when extrapolated backwards to the star stage of our planet, are in harmony with the conditions under which matter exists at that stage, according to the observations of the astronomer. These general reflections bring me to one of the cardinal assumptions on which the evolution of the Earth has been based, and all the theories hitherto propounded, however divergent they may be in other respects, it has been accepted, holy word salad, as an unassailable basic conception that the Earth, by cooling from the high temperature state as a star to the low temperature as a planet, has been shrinking, which means that its density has been increasing. It seems to be so convincingly supported by the general behavior of matter to expand by heating and to contract by cooling, and by the fact that in the star stage, in which undoubtedly the Earth had once been in the dim past, matter is found to be in an attenuated gaseous condition, that geologists have accepted the theory of a shrinking Earth as an unchallengeable axiom. Now, this is where he goes into the expanding portion of it. But I haven't seen where he draws the conclusion to where Earth had been forming in the interior of the star, which then pressurized it and then expanded outwards. For those people who have done scuba diving, my wife requested me to explain this. If you go scuba diving, you take an empty balloon, you bring it down with you, maybe about 100 feet, and you take your regularity mouth and you blow into the balloon at about 100 feet below the surface, which is maybe about 3 atmosphere. And then you tie it off with the air inside, and then you come up slowly. Obviously, you have your plan. As long as it's in accordance with your dive plan, you go up slowly, so you don't get those nitrogen bends, and you'll see that balloon will start expanding outward slowly. And then once you get to the surface, you'll see that the balloon is a lot bigger than what you started with, because when you blew it up in the bottom, 100 feet below the surface, you actually were blowing with compressed air when you did that. And that's similar to what happened with the Earth. When the Earth was forming in the interior of the star, it was forming under extreme temperatures and pressures. So naturally, when you remove that thick atmosphere over time, the interior ball that had been forming in the center, the really dense, hot ball, will start expanding outwards slowly because of the rigidity of the atmosphere, which would cause the Earth to expand outwards slightly as a more or less rigid body in terms of versus gaseous or plasmatic material. And I think that's what he's actually arguing for, but he doesn't actually say it like that. To be honest, I was trying to read it haphazardly, looking for keywords and things, but the fact that he stated that star stage of our planet is just wow. This is an official, the Journal of the Astronomical Society of South Africa. Of course, it's defunct now because they ran into financial issues in the past, but an actual astronomer wrote that in an actual astronomy journal. So that kind of beats Oparin, who was a biochemist, wouldn't you say? And also, since this guy was 70 when we wrote this, it's very likely that he had been thinking of this idea for decades before he even wrote it down in an official wording like this. So which means, since he's German, there's probably some German articles or publications that he has that outline this idea that supersede Oparin. And he's kind of, in this little small circle we have, he's kind of taken as the one who first pushed it, but that might not be so. A biochemist was probably beaten out by a genuine astronomer who had the same idea. And I'll keep on looking for more publications by him. Maybe use Google Translate to try to figure out some of these German documents. Maybe I can find them somewhere deep in the internet. But I just wanted to share that because if he was born in 1866, that means he'd totally beat Upern. I discovered this when I was 26. So for me to discover something at 26 and then publish it at 70, something else is going on here. You know what I mean? There was definitely talk about this specific idea many decades beforehand. It's highly unlikely that he woke up one morning when he turns on his 70th birthday and said, I'm going to write this down and publish it. The chances are more likely he was in his 30s, which would place him firmly before the year 1900, which means he'd totally be Alexander Oparin for this idea, which means Oparin probably saw it from him and then took it to another conclusion in another avenue. So Oparin is actually the branch to that root tree. Anyways, later.